There we go. Welcome to Quarkus Insights, SIP number 31, the last one of 20 some year 2020. And yeah, we got a few people here. We're going to talk about RESTEasy Reactive, but we have a few news first. One is that Stuart is, I think he was sick today, or didn't get sleep, one or the two. So he'll just probably both. Yeah. But we got Steph and Georgios, and we'll be fine. We got Quarkus 1.10.3. We got a few of those run out the last couple of weeks. Do you remember what's the big thing under? It's like small, minor. Oh, not minor.
But 1.10.3 was a lot of fixes to the 1.10.2 that we had released before. So obviously, everyone should upgrade. Everyone on 1.10 should upgrade to it.
And we should have 1.11 beta sometimes this week if everything goes fine. And then there's a little piece of news that I'm going to put this link. So there's a thing, we have this developer tools group, and they made a thing called OpenShift Developer Sandbox. And I'll give you a link here. And what's cool about this is this gives you an OpenShift instance with 3 namespaces and fairly decent sized nodes, like 8-9 gigs, something. 15 gigs of storage, so it's big enough to play with for sure, but it only runs for 14 days, so you can basically do any kind of development you want to do, and then it shuts down, and then you can reapply again and get the same kind of resources. But it only requires a developer account, so no credit card, no kind of thing. But the reason I mentioned it is not like a commercial for Red Hat, but that's actually a nice place where we know and we can guarantee that all the examples we have for around deployment and stuff actually works out of the box. So if you ever want to try Quarkus on OpenShift or any Kubernetes without having to run it locally, that's a place to go. So anyway, I just want to mention it because I was so excited when it came out last week. It just worked. So that was good. Okay, for those who haven't been here, and just remind everyone, we do this, but we'll get started here on the topic of RESTEasy Reactive. And then anyone in the chat can just ask a question. And while Steph and Georgios is kind of, I don't know, waving their hands around what they're going to talk about, we'll interrupt and, or not interrupt, we'll try and be nice and ask the question for you guys. But yeah. And I think, Georgia, Steph, you actually been on the call before, so maybe just do a quick one. So, Steph, how do you get involved in this stuff? And then,
how do I get involved in this stuff? By bad luck, I guess, for me. No, actually, it's pretty cool. I've been a big-time RESTEasy user for a lot of time. In fact, I was even using RESTEasy and contributing to RESTEasy before I joined Red Hat 10 years ago. So I have a lot of long-time experience with RESTEasy and REST in general in Java. And so when the topic came, when the question came about trying to make the whole thing work on and be more reactive and work on async use cases and have more async performance, then naturally I was involved in the discussions.
Oh. And Georgios, well, we know you, but
well, yeah, how I got involved with this one, with RESTEasy Reactive, is that I remember that Stuart and Steph were talking about this like sometime over the summer. And it's like right before I went on PTO, right? So right before I went on PTO, I send a message to Stuart, and I'm like, if you guys want my help, count me in. This is something I'm looking forward to for after PTO. So yeah, I said, sure, there's a ton of work to do because like passing the JAXRS TCK is not going to be fun. So yeah, that's how I got involved with this. And I had RESTEasy experience as a developer, basically when I did the Spring Web stuff for Quarkus, I had to do some work on RESTEasy, and that's how I knew like some of the code base.
Awesome, cool. Well, let's get into it. Like, who of you want to drive on saying what RESTEasy Reactive is? Maybe we can start from there.
I think we should I think Steph could take if he wants to most of the talk, and then I can later on do the little demo stuff that I prepared real quickly.
All right. So the idea behind RESTEasy Reactive is to make a new engine for RESTEasy, which at the core is fundamentally asynchronous. Because we came to notice that it's very hard if you have a truly blocking core, something that is architected around blocking I/O, to support non-blocking use cases. We've had various success adding asynchronous capabilities to RESTEasy over the years, supporting asynchronous filters, asynchronous return types in the endpoint methods, and lately asynchronous I/O. But every time it was really a lot of work trying to get this in and work around the fact that the core is really engineered to be blocking. The whole specification of JAXRS that RESTEasy implements is also based around blocking. So there are some limitations as to what we can do. And in fact, we've seen this with other systems as well, including Vertex. When the base of the framework is implemented supporting async from the start, then it becomes much easier first to support async, but also to support blocking use cases on top of it. So if you have to support both blocking and non-blocking in a framework, it's really much easier if the core is non-blocking and supports it, because it's easier to support non-blocking on top of, support both cases on top of non-blocking rather than on top of blocking I/O. So we wanted to start with something fresh that had great performance for asynchronous I/O and reactive use cases. We have a bunch of benchmarks that, such as the Tech Empower benchmark, where Quarkus has a decent score, and we looked at it and we looked at how to improve it, and all the other frameworks were basically offloading stuff to non-blocking REST handlers, and we had to support something like that if we wanted to get great performance. On top of that, there are a lot of new things happening around non-blocking at the moment, such as the Hibernate Reactive has been announced recently, which runs on top of the SQL client, the reactive SQL client that Vertex implements. And so if we wanted to have a story that would support asynchronous and reactive from all ends of the backend, so the REST framework, the database access, the ORM access, then we felt it would be better if we had something that was truly solid and could really implement fast async access to the backend. So we started working on this, and the fun thing is that as we were looking at this and looking at ways to make it support non-blocking in an easier way for users, we also started noticing things we could actually add on top of the JAXRS specification to make it easier for users to write code. And we have actually added quite a lot of features on top of JAXRS that make it easier to write your endpoints. And we can talk about them a bit later. We'll probably have a demo. But this is not a release with just async support. It's also a lot of performance improvements. It's also a lot of new features and user experience improvements. And also the fact that with this RESTEasy Reactive, we also moved a lot of the configuration and setup of the endpoints at build time. And we do a lot of code generation so that when the request comes, we are going to invoke only the code that we know at build time that you are going to need for serialization, deserialization, for validation, for everything. All the bits are wired up at build time, and the pipeline that your REST call will go through is optimized for your endpoint, and you're not going to pay the price of things you don't need, because we figured this all out at build time and we streamlined it.
Cool. So basically, what I hear is RESTEasy Reactive is a new implementation of JAXRS or REST framework, so that we can build both async and blocking features in and fix them easier. And then
Yes.
because it's like built now in 2020 and not in, I don't know when RESTEasy started, 2005.
More than 10 years ago. So yeah.
We can benefit from all that. So is this just all backend stuff? Like as in does the user notice? Is there anything he sees or in that sense?
So yeah, so I talked about the backend, but first I have to clarify that I talk about JAXRS a lot. And while it's true that we pass most of the TCK for JAXRS, we don't actually implement the entirety of the spec. We took some liberty as to which parts of the spec we would implement, and in fact there's, I think, 2 or 3% of the spec that we don't implement for various reasons. Some including that we plan to support them later, and we felt it was not urgent to support those use cases because they were obscure, and some others that we just don't plan to support because we think the use cases don't actually make any sense. Maybe they made sense 15 years ago, but not anymore. And so we also couldn't justify being held back by those things that we didn't feel made sense to, if they would endanger performance. So there's that. There's the server part, but JAXRS also comes with a client API, and we also have a client implementation for RESTEasy Reactive, and the client supports exactly the same architecture as the server, which means that it can be non-blocking all the way. So you can start suspending the request at any point in the pipeline, whether it's in a filter or in an interceptor or inside your handler, and it will cost you nothing to do that because it's just free. As a user, would you notice? That's a very good question. If you want to port your application, your Quarkus application that currently works with the standard RESTEasy, and make it run on RESTEasy Reactive, it's very likely that it will just work. Now, there is one caveat here, which is that RESTEasy Reactive by default assumes that the endpoint is going to be non-blocking, whereas the default is true for the current RESTEasy. So at the moment, we have Quarkus, which is really fast. It's built around Netty and Vertex and Async IO all the way. But the minute it gets a request, if it determines that it needs to hand it off to RESTEasy, it's going to offload that request into a worker pool. So it's going to allocate a worker thread and say, okay, this thread handles this response, and when it's ready, I'll do the IO and send it over back to the client. Which means that we're limited by the number of concurrent clients that we can serve at the same time by the worker pool. And with RESTEasy Reactive, we said that the default is going to be the opposite. We're going to assume that all the requests are going to be handled directly on the IO thread, and considered that if it needs to do something else, it will return something asynchronous like a mutiny pipeline, a single, a multi, or whatever, or even a completion stage, and then do the async operation later, get notified, and do the async operation exactly the same way that every other reactive pipeline works. And we don't need to allocate a thread for it, but you can also opt out and add the add blocking annotation that is new in SmallRye Commons annotations. That is something that you can use all over the stack in Quarkus now. We've standardized on this blocking annotation. And whenever you need to be blocking, then you can add this annotation to your endpoint method, and we'll allocate a worker thread for you.
Can you add that on a package level, or is it only on classes?
It's classes and methods currently.
Right. But so the thing is that if within your endpoint method you're going to do traditional Hibernate ORM or ORM with panache, which is blocking because it uses JDBC, which is a blocking API, then you're going to want to specify that your methods are blocking. If you're using the new Hibernate Reactive or Hibernate Reactive with panache, then you are not going to need those blocking annotations because everything is going to be handled by the new SQL client of Vertex and do completely reactive connection to the databases.
Well, I guess you can show that in the demo how that works.
Yeah.
So,
one of the great things too is, I mean, from you mentioned asynchronous, all this asynchronous capabilities, and then the performance that comes from being able to use that. That's fantastic. But the benefits apply not to just the async scenario, but they also apply to the blocking scenario, right? If I understand correctly, is you actually get better performance even if you have a blocking use case with RESTEasy Reactive than our existing RESTEasy provider. And then a second thing I was going to ask is, what if I'm not ready yet for using RESTEasy Reactive? Do I have to switch? Do I have to move over to it?
You don't have to switch. We still support both traditional RESTEasy and the RESTEasy Reactive. But as you said, you are going to get better performance with RESTEasy Reactive, and that's probably not due to the fact that we still, in this case, if you're using it in a blocking way, then you're still going to be scheduled on a worker thread, so you're still going to pay for that. But thanks to all the optimizations we did with moving all the setup and the wiring and even generating lots of bytecode to be able to get great runtime performance, you're still going to benefit, as you said, from performance. So I would encourage you to switch, with the caveat though that RESTEasy, the traditional RESTEasy has at the moment a lot more extensions than RESTEasy Reactive, precisely because it's almost 15 years old. It's a very mature project, so it supports a lot of use cases, including lots of use cases that are outdated, that came 15 years ago, and that we are probably not going to port and support in RESTEasy Reactive because we're going to focus on the technologies of right now. So if you're using one of those things, then definitely keep on using RESTEasy blocking, then it's going to be fine. If you're not, if you're using only modern features and so you can probably switch to RESTEasy Reactive. And if we don't support those features because we start from scratch, then just file an issue report and ask us, and we'll see how we can improve it and support the use cases that we're missing.
Very cool. So Antonio, I'm not sure if you said this, but he is asking, what about MicroProfile REST client? Will it also become reactive?
So that's a very good question. At the moment, we have an implementation of MicroProfile REST client which uses RESTEasy. And if I'm not mistaken, the classic RESTEasy, if I'm not mistaken, it uses the proxy client of RESTEasy, because RESTEasy has two clients. It has the client API as mandated by JAXRS, which is what we also implemented. It also has a proxy API, which allows you to get a proxy to an interface of your REST call, where the definition of the REST endpoint is specified by the Java interface, and then you make calls to the object as if they were the endpoint. So that's what we call the proxy client. We also have a version of that in RESTEasy Reactive, but it's not complete yet. And the MicroProfile client uses that proxy client from RESTEasy Classic at the moment in SmallRye, and we definitely plan to support it so that we could choose between the two and make it also run on RESTEasy Reactive. But we haven't done that yet. But if we support this, then you're going to get another benefit, which is that at the moment the HTTP client for RESTEasy requires the Apache HTTP client as a backend, which is doing blocking IO. And if then we are able to switch to the RESTEasy Reactive client, we use the Vertex HTTP client backend, which supports Async IO, and also means that because we already have the Vertex dependency, you're going to have less dependencies, so your native binary will be smaller because we don't need the HTTP client anymore.
Cool. So the nice thing about all this too is that, I mean, when you talk about all these different pieces coming together on being async, it's all sharing the same event loop, right? Like so you have the same processing on the IO thread going from the server back out to as a client to an external service, and then when IO can't proceed, then it simply moves on to other tasks. The same thread picks up later and can then process data bidirectionally. So that's a huge benefit, not just from the benefits you get from using RESTEasy Reactive directly, but also the whole experience that you have when you write an application in Quarkus, that everything is using as minimal resources as possible to execute that the resource.
That's super important because you can think of like a larger application that could use RESTEasy Reactive. It could be using a Kafka client, like with small reactive messaging, could be using Hibernate Reactive. So yeah, all that stuff now would be based on the same Vertex. So you're saving like a lot, both on like all the classes you're loading and all the management that's being done. That's so that was the plan you guys had from the start, right? It's just that there was not enough time to execute this whole plan from day one, right?
It's a multi-year plan, and we're still working on it.
Quarkus years, though, right? So yeah. Quarkus year is like a couple of weeks.
No, we have still lots of things that we're going to announce. 2020. Well, we might be able to squeeze it, but probably early 2021. But just to make it clear for the people that don't understand exactly why they should care about Async IO and stuff, let's take a very simple example. You have a REST endpoint, and it calls an HTTP client to something else, a third-party service, let's say Google, which is down at the moment, right? So the current model, if you have a worker pool and you offload the work to a worker pool, is you get a connection, you create a worker thread, or you get it from a pool, and then you tell it, look, go work on this thread. So you start blocking a thread. The thread is going to make an HTTP connection to Google, and it's unresponsive. So it's going to wait on I/O for a long time. And the entire duration of this call, the thread is blocked. It's not serving any other request. It's just, even if the other requests are not connecting to Google, then they can't complete because we have a bunch of threads just blocked on I/O for Google. Now, let's suppose at some point Google is up again, and then these threads can go on, but then they need to transfer the answer to the client. And the client is, it's using 3G, it's getting a bad connection, so the I/O is going to take forever to reach it and to hand it to them. And so, again, we're blocking all these threads, and they can't serve anybody else. Now, if you're doing async, then we're not spawning any thread. We're getting the request only when I/O is done. And then we serve the request, and we say, OK, we're going to use this new client to connect to Google, which is using the async client, HTTP client of Vertex underneath. And it's also non-blocking. So we're not allocating any thread. We're not blocking anybody. We're waiting for I/O, but it's free. We're not using any resources waiting for 10,000 connections to Google to resume because we have 10,000 pending connections to Google, and they're all hung up, but it's free. We're not using CPU, we're not using memory, we're not using threads. And the minute it resumes, then we can run the code again and get it to complete and push it to the client. And again, if the client is not responding, well, again, we're just waiting for free. We're not allocating anything, and we get this, in their own time. They get back to us, and we can resume sending I/O, or they don't, and we get a timeout and we drop it. And all that is free. So it allows your application to degrade much nicer, because if one request is hung on I/O, you're not eating anything, and you can serve all the other requests, and you get, it's a much fairer for the people using your website if they have bad connections or good connections.
Simon makes a joke. He says, it's free for us, but not for Google. Is that why it's down? So, by the way, we are close to half an hour. We haven't seen code yet. That's not normal. Can you
Yeah.
show something and make it more concrete than
Yes. Absolutely.
us
Absolutely.
talking back and forth?
Okay. So, is my screen visible?
I'll give you that into. There we go.
Okay.
It's tiny. You have to make that bigger.
It's tiny.
Yeah.
Wow.
So while you're getting that bigger, maybe Steph can answer this one. Tokyo is saying more bigger. Go bigger.
Bigger.
Yeah. Tokyo says client talks to service A is reactive, service B is blocking, and to service C is the internet benefit using reactive RESTeasy in this scenario.
Whose scenario? I mean, which services are we talking about? If they're separate, then service A is certainly going to benefit because while it's waiting for service B to answer, it's going to be waiting without doing anything, and so it will benefit. Service B is not going to benefit, but that's fine. It's using blocking RESTeasy. It has probably good reasons to do that. So. Yeah, I'm not sure how to answer that.
But that's it helps. Yeah, where it runs, it gets you'll be able to have higher throughput basically, right? And then a follow up, which is I think is a good one from Eve Chen saying, so is there any drawback using it? Because otherwise, why have you been doing blocking IO for so long?
Well, because blocking was easier to implement, right? So.
That's a funny thing because I come from a C background and already 20 years ago the whole world made the switch to non-blocking async and stuff, and looking at Java how late it got the select calls and async IO support and NIO2, I'm still puzzled that we're still not getting async IO for files. It's. Some of these things have been taken for granted by pretty much everybody else in the industry, except in the Java world. But yeah, async IO is not something that is worth suspending a thread for. Threads are expensive. They allocate quite a large amount of memory and resources. They're not optimal to schedule, especially to serve requests. If you look at even HTTP, the Apache HTTP server switch to Async IO 20 years ago, it's always best to offload Async IO to an event loop. The fact that Java took so long to do this is a bit of a puzzle, but right now we have all the pieces together, especially with Vertex and Netty, to support this in a way that is less bothersome to users. Because I think the main drawback of going async is the style of programming that you're forced to use to support it, because it's more complex. Because the programming languages that we have are built around the notion of threads and sequential and not really async programming. If you look at JavaScript, which is built not from the ground up, but at least for the last 15 years around async APIs, it uses callbacks a lot, and that's a mess. People are pulling their hairs over this because it's hard to maintain. And so they've come up with other APIs such as promises, and eventually what ended up being a Mutiny in Quarkus. We have a really great reactive programming API now with unis and multis, and those make it really easier to build the asynchronous pipelines that we need to build to support async programming. I think it's some of the parts that make it easier now to write async programming in Quarkus than it would have been in the past if we had to do it with callbacks or with low-level APIs.
Well, I can see other questions. Let's do the example first.
Okay. Yeah. Okay. So here, I'll start super simple, right? This is the getting started quick start that we have. The regular Quarkus getting started quick start that we have in our guide. So this is using the regular RESTeasy, the RESTeasy Classic, let's say, with Jackson, right? Well, it shouldn't have Jackson, but anyway, let's say just RESTeasy. And it's got a single endpoint and that's all it does. So what I wanted to show here is basically that if I create it and start it, I wanted to show like a horrible benchmark of what this looks like on my machine. This is like totally unscientific. If you watched our previous show with John, this is not the way to do benchmarks, you'll know. But it'll give you an indication of like what kind of difference we're talking about here, right? So here, we're just hitting a hello endpoint. And what I'm going to do is, first I'm going to warm it up. So I'm hitting localhost hello now with 2 threads. Yes, that I can. Let's see, preferences.
Yes.
Okay. So now what I'm doing, I'm just warming it up, right? Because we need to warm, in any Java benchmark, you need to let the JIT compiler compile the hot path in order to get the optimal code to see like what their actual performance. So I warmed it up here a little. And what I'm going to do now, hopefully my machine will be able to handle this and streaming and everything. Thanks to AMD, though, I think I'm covered. So what I'm doing here right now, I'm going to hit it with like 10 threads, 200 connections for like 40 seconds. Again, totally unscientific because I've got the server and the client running on the same machine. I've got my IDE open. I'm streaming stuff. So this is like totally unscientific, right? There is no the client I'm using, the benchmark I'm using, it doesn't use like the bias, the whatever, I don't remember what the term is, but anyway. So this is a bad benchmark, but it'll give you a very good example of what is compared to what we've achieved with RESTEasy Reactive. So just keep in mind this number: 363,378 requests per second to a hello world style endpoint, right? So this is RESTEasy proper on my machine. So if I take this turn it off, then I change the dependency to RESTEasy Reactive. Also see here that this started on my machine. The hello world with regular RESTEasy started in 610 milliseconds. Now I'm going to, it's the same application, nothing changes because this doesn't have anything. So like Stéphane said, we reimplement JAXRS. So these are just the regular JAXRS annotations. You don't have to change anything in this case, and in most cases actually. So I'm going to start, I built the application with RESTEasy Reactive. I'm going to start it. It starts faster, so it starts in 528 instead of 610, which that's a small gain, obviously, but it's a gain, and there's a gain in the memory too. So now let's get to the more important stuff. Remember this number, right? 363,000 is what we got on my first benchmark. So now I'm going to warm it up again for 30 seconds. That won't give me a good number, obviously, because it's just warming up. And then I'm going to hit it again with a big load with 10 threads, 200 connections for 40 seconds. And we'll see what the number here is. I'll like, what do you guys think is the magnitude of the difference is, right? It'd be like 5% better, 10% better. What do you think?
3? I have no idea.
Isn't that a call to the people commenting on the chat? Not to us, right?
Yeah. Well,
Yeah.
So either comment on the chat and give your prediction.
Yeah.
Yeah.
You have 40 seconds. So.
You have 40 seconds to add your predictions here. So this is just a hello world, right? We'll be seeing like how many requests per second, just the switch from RESTEasy, Quarkus RESTEasy to Quarkus RESTEasy Reactive will give us. I'm so glad I bought a new computer because I don't think that I could do this with my laptop. So many threads and streaming everything and have the IDE open.
I think it will take 40 seconds.
That's a pretty good prediction. I think you're going to be spot on. So what we got here was 837,737. So that, as you can see, is, let's see, calculator. If I do 800 and
hey, we're programmers. We're supposed to be able to do all this in our head, right?
I can't. Maybe you
We're
guys can.
programmers, not computers.
So okay,
Close to
this
double.
is it's more than double. Yeah, so it's 230%. Well, 130% better. So it's 2.3 times more throughput from the exact same application, right? So that's just to get back to what Steph mentioned earlier, that with all this work that we did with switching to using non-blocking IO on the same event loop thread and all the build time optimization, you get this, like, I would say, for me, like the first time I saw Stuart and Steph working on this and they showed me numbers like this, it was like, I thought it was like just mind blowing. And then the fact that we were able to implement the whole specification and still be able to achieve these numbers is, again, great. But like Steph said, this is only one part, right? That's like the performance part. But what happens? What does it look like?
And just to be clear here, like that assumes also that your implementation, that whatever your service is doing, is async too, right?
Yes, this is completely async. So because this is just returning a string, it'll be async, right? So as Steph said earlier, you would see even more benefit if you're here, you're calling stuff that was actually blocking and waiting. You wouldn't see it in the throughput probably, but what you would see if you did a proper benchmark where you were measuring the latencies, like the 95%, 99% latencies, in a blocking implementation, you would start to see, as you were blocking a lot, you would see like the tail end would like explode, right? You'd see like horrendous times as because you wouldn't have enough threads to service. But with this, you should get, as Steph said, a lot more predictable and a lot performance that degrades so much more smoothly.
Yeah.
So do we have questions, or do you want me to move on to like some of the other?
Let's move on, because you're collecting a few questions here that fits.
Okay. So the next thing I wanted to show real quick is Steph mentioned like we have a couple of new like APIs that for writing stuff. So I just want to do this really quick. This is what this is an example of like what Steph was talking about. Right, so this is a filter, a container request filter. So in JAXRS, this means that this is what you use in order to like intercept requests, right? And this to me looks like really old style. This is like, as Steph said, this is like 10, 15-year-old style of writing stuff, right? Because this is where you have to implement an interface and then you have no idea like how to get stuff. You're using this magic like context thing here, which I never really understood. And Steph then explained to me that I asked him like, why do you not use inject here? And he's like, because, well, when JAXRS came out, there was no CDI. So it's just another thing that like, so this stuff, old stuff accumulates. So we really wanted to do something that looked a little better, right? So again, I'm using RESTEasy Reactive here. So what I can do is I can change this. So first, let me run this in the Quarkus in the dev mode. So I'm going to go to see. So just to show you what it's supposed to print. Okay, so we have dev mode here, and it will respond here, right? So I'm just hitting a fruits endpoint, and what I want to see is the filter, right? So the filter prints some of this stuff here. So for every request it gets, it prints stuff. But this is the older way, and more, let's say, more like boilerplate way of doing things. So we came up with like a better API to do this kind of stuff, and we'll say new logging filter. And it's just a class, doesn't have to implement anything. I'll go public void filter, and I'll add this annotation, the server request filter. So just the same way like you're using in JAXRS, you would just go ahead and when you use like get or path or stuff like that, we wanted to bring the same like style of usage for the filters as well. And there's all the other stuff too, but we don't have much time, so I'm just going to show the filter. So how would I like implement the same filter here? So I could just basically take these parameters, right, and I could add them to the filter method, and that's the most reasonable way to write this, right? Because these are actually parameters that you would, if you were writing like your own code, you would want to have these parameterized here and not as fields of a class, which is just like very artificial. And this is the style that you could write this in a JAXRS method, resource method too, right? So why not be able to write it as a filter in the filter? So if I just copy and paste this stuff here, and I'll just say, well, the context we don't really need. I can just use get raw method here. Oh, no, sorry. Yes, request. There's a raw method. Okay. And I do need a logger as well. So I'll take this and copy it.
We're working on getting rid of the logger as well.
yeah, we'll get to that one as well. So I removed the old filter, new request, and I added this new style logger here. And of course, since this is dev mode, this is Quarkus dev mode, I can just restart and it'll work automatically. So you see here that I wrote something that made a lot more sense, and it's a lot more consistent with JAXRS itself too, right? And it does the same thing. And in the document, the Java doc of the request filter, it tells you like what you can and can't use as parameters. And Steph is also working on this cool thing that will make will give you a better developer experience writing this kind of stuff. We should have something in early 2021. And I also wanted to show you, like Steph talked about earlier, very briefly about async filters. Async filters are not part of the JAXRS spec, right? So the JAXRS spec, like Steph mentioned, is really like blocking oriented. So it assumes, maybe not explicitly, but implicitly, it kind of assumes that everything like runs on the same thread. But we don't have to assume that here, right? So if you had a filter that, let's say, did some kind of synchronous IO or whatever in order to determine something, you don't have to do anything special to write this in Quarkus, right? With RESTEasy Reactive, you could just say, well, this is a totally contrived example, but you could just return a uni from this filter. And here I'm just gonna like write this very dumb example. And to show you, return uni create from, oh, not null deferred, null item. So basically, when you return a uni, Quarkus and RESTEasy Reactive know that this filter needs to suspend, which means it needs to not execute anything, not block anything. And when it comes back with the result, which in this case is void, then it can continue the processing. And like Steph said, it doesn't block anything at all. So you can continue to use the non-blocking style, even for stuff that isn't part of the actual JAXRS specification, and you do it in a very, very natural way. So again, you see that it just worked, right? Again, of course, event loop. So everything just works great.
So we got a few questions now, though. I think we should get in.
Yes.
So one was just the first, when you start talking about stuff that was outside the spec. And Werner says,
I can't hear you.
You can't hear me.
Can you hear me? Because I can't hear anything.
Nothing. Hey. Google's going down.
I don't know if I lost you guys, but I can't hear anything. I don't know if I'm on now, to be honest, because I can't hear you guys at all.
You are on. We hear you all.
So I'll answer the question. Will this style of filter writing be pushed back into the JAXRS spec? We can. I think Georgios is trying to communicate. we do plan to talk to the JAXRS spec about this. Obviously, the idea, and this is an idea that is shared by MicroProfile as well, and Quarkus. We want to do as much innovation as possible, but we do want to first experiment and get feedback, real-world feedback from usages before we standardize on anything. And so this is, experimentation takes place. Oh, I can hear Max now. Experimentation can take place in RESTEasy Reactive, and once we're happy with everything, we can talk with the JAXRS people about this. But yeah, we do hope that this will be able to make it back to JAXRS if they're interested, because it's as Giorgio said, it is much more consistent to do it this way because. To be consistent with the way that you write your endpoint methods. He showed that you can return a uni from a filter, and it is also the case from an endpoint method. You can return a uni or a multi or anything that supports async. The JAXRS spec only specifies that we can return a completion stage, but Quarkus supports more use cases, whether it's in RESTEasy Reactive or RESTEasy Classic. And so we're just extending this style of programming to all the other parts. It's filters, but it's also interceptors. It's going to be everywhere. We look at the API. We look at it from a fresh perspective, from user experience point of view. Okay, how optimal is this API? Do I want to keep on writing things this way? And if not, we look at how we can improve it. And which is why I mentioned that we're also working on something to make logging easier. Earlier, he said you can use the same API to the exact same endpoint to return the hello world string. Actually, you can, in RESTEasy Reactive, you can even drop the produces text plain, because that's the default if your method returns a string. Similarly for JSON as well. So there are lots of things where we're trying to improve the API and make it better. And we hope, yes, that eventually they'll make it to the spec. But we first have to experiment and validate it in RESTEasy Reactive and RESTEasy, previously RESTEasy Classic.
So one thing is we'll always do more than the standard itself, right? Like, so we always have the standard as a baseline, but Quarkus isn't just, we don't artificially limit ourselves to standards or particular APIs. We want the whole environment to be cohesive. So like, that's what Panache was all about, right? Like, you could use Hibernate, but it made it even simpler, right? And this will carry through from every framework. So the idea being that when you solve a problem, it takes as minimal code as possible to solve that problem. That's our mission.
Can you hear me again?
Yes.
Yes.
Okay. Weird. Okay. So yeah, something about the screen share apparently broke things, but let's do this. So we had Antonio had something about if you add he asked this when you did the test, right? So if you add the blocking to the endpoint, you'll get the same performance as you had previously?
No, obviously not. No, because when you offload to a worker pool,
I think he's asking as previously the RESTEasy Classic.
If that's what he means, then we can do it right now.
Yeah, I was gonna say, do it.
Yeah, I'll do it right now.
Let's see how we share. And then I just have a cycle. I just thought about it when. Let's see what happens when you. I'll just ask my question before I turn on the screen in case I lose the audio again.
Mm-hmm.
So, like on the filtering thing, you looked at the return type to signal it was blocking or not.
Yes.
Is there a reason why we don't do that for the method?
No. It's not. It doesn't signal if it's blocking or not. No, that is not correct.
Okay.
What it signals is that the filter just suspends, which means that it, like, let's say, disappears and reappears when the result comes back. It does not mean that that anything that goes on in the filter is being offloaded to a different thread. That is two different things, right? Because I'm assuming what you have in mind is like what I think Micronaut did in version 1, where they were looking at the return type of a method and trying to determine like which thread they were supposed to run on. But they eventually figured out that, like, based on user feedback, that was a bad idea, and it's better to give explicit control to the user for that. But no, this is not that, right?
Cool. Okay, got it. So I'm gonna turn on the screen. Let's see if
Yeah.
if I lose. Or you lose me again. But there we go.
Okay, so I added blocking, and let's hit it. Okay, now we need to warm up again.
Okay, while it's running, I'll just Antonio had another one. He says like, what about testing? Does anything just change? Like any change in testing reactive endpoints with REST assured?
Now,
Or is it just
from the
same,
point of view of users of REST APIs, the fact that the REST API is implemented in a blocking or an async way has zero impact, zero visibility, aside from getting better performance. But no, so there's no change that you need to do in your test to actually hit those. And now in the future, we could look at how to make it easier to test, but that's completely orthogonal.
Yeah.
And besides, your test is likely to be running sequentially, and I'm not sure that you're going to run all your HTTP tests in parallel, and so it probably doesn't make sense at this point to start working on async HTTP for tests. I don't think you would get such a great workload as you would get from exposing your servers to the internet.
Yeah.
Mm-hmm.
Well, that's good. But that also mean it's just a kind of proof point that this is more a back-end thing, right? Yeah.
Right, exactly, yeah. Okay, so the results came back when I added blocking. Okay, so let's go back to the numbers with RESTEasy Classic were 363. With RESTEasy Reactive and non-blocking, it was 837. And with RESTEasy Reactive and blocking, it's 578. So again, you see, like, I don't know, like 50% better than RESTEasy Classic when you use blocking.
Yeah, so that's basically just the internals of RESTEasy that it's been improved, basically.
Yeah, because we moved a lot of stuff at build time. All the configuration of how we handle the request is moved at build time, and we generate lots of bytecode rather than use reflection. So it is going to be really optimal. Even if you use offload stuff to a thread pool, you're still going to pay for the offload to the thread pool, but you're going to benefit from a lot of things.
Yeah, and one thing to keep in mind is that the in this particular example where you're returning a reply immediately, that's essentially returned directly from memory. If you compare the relative difference of that workload with the workload of offloading to a thread, you're going to see a very stark contrast. If you have like a lot of work that's being done in that computation that would be more comparable to the offload to a thread, then the penalty wouldn't be as high. But then the big piece of the whole reason why you would use reactive as well is whenever you start to have many clients and you have you're trying not to block and trying to conserve thread resources. So while it would be better when the actual method that you wrote does a lot more, at a certain point it would actually start to hit a wall where you start to hit the limit of your thread pool, and this would be handled better in a reactive fashion. So when you're comparing the scenarios, it's a really good idea to think about like what am I actually building, like what's the problem I'm trying to solve, and then like which technical approach is better. Like if you have a request that's returning data instantly, there's no reason to block. So you should just use the RESTEasy Reactive approach, right? If you have something where it's kind of more involved, does a lot of things, but you don't expect to have a huge amount of traffic on that particular endpoint, well then, just use blocking style because that's the easier programming model, right? But if you want to have a system that, if a request comes in and you really need the optimal performance as possible and you're involving client calls and things that could possibly block there, then you're back again to, okay, now I want to use the reactive approach. So I'm not sure if you guys have the same opinion on how to do it, but that would be like my recommendation on how to think about it. Because with Quarkus, we've not tried to say only reactive is the only way you could develop applications. What we're saying is use the best tool for the job, and we'll give you the full toolkit, right?
Absolutely, yeah.
And so just for me to get my head around, so you're defaulting to assuming that since you're using RESTEasy Reactive, your endpoints are async. So if you don't realize that as a developer,
good. Okay, good point.
Then I guess
let me show you.
I was wondering what happened if you can detect it, or if
you'll see. Okay, so let's say I am going to use like a regular Hibernate, right? Just old blocking style Hibernate, not the Hibernate Reactive. So I have the Hibernate ORM quick start here. And I'm going to use RESTEasy Reactive. Jackson, I'll take away this dependency. And Hibernate ORM quick start. And let me see if there's anything here. Okay, so this application scope, but it doesn't have to be. Okay, this in Hibernate, in RESTEasy Reactive, you don't need this. You don't need these path params at all because we can automatically determine that which is which. So I'm taking them away anyway. I'll do a NVN clean, and I'll show Quarkus dev. Okay, so to your question, right? So okay, yeah, the package is missing. So here it's just using an entity manager. Oh, come on. Okay, there you go. Here we're using an entity manager, and we're returning a bunch of, let's say, fruits, right? Okay, so I think if I hit 8080 and I hit fruit, I should get its fruits. And there you go. That's your answer. You attempted to perform a blocking operation on an IO thread. And that is nowhere in your user code, right? Your user code is just returning the stuff, and RESTEasy Reactive is smart enough to know that, yeah, you're not supposed to do that.
How does it find that?
Because
don't tell, it's a secret.
I won't tell anyone except the ones who are listening. But yeah.
Well, that's the awesome thing when you have full control of your stack, right? That means that in cases like this, where we're using the same vertex everywhere, and we're using, and we know what the worker threads are, and we know what the the worker pool threads are, and we know what the event loop threads are, then we know that an IO, that when the control is supposed to flow here, then you've done something that takes a while, that does blocking IO, and you're doing it on the wrong thread, we know what that thread is, right? So here, Quarkus knows what thread is being used, and it's not the right thread. So
awesome. You know, this I missed this completely. This makes me much more like, oh, now I'm the default to async is much better. So this is actually, Antonio has this, was the same thing I had in my head, was like, so if you go now add a blocking to it, this will work, right?
Yes.
Very, very good question, and let's see it.
Yeah, you know, which previously in REST frameworks, if you were to, or sorry, in asynchronous frameworks, if you were to stick a blocking call in it, you wouldn't get an error message. You would just it would look like it worked, maybe even, and then all of a sudden you get any kind of load, and then you're like, oh my god, this performance is terrible. Why is it terrible? And then 3 hours later, you're like, oh crap, I put a blocking call in my reactive method. So this is a huge lifesaver.
and I have to get away from my Christmas dinner to go fix it.
Yeah, that's cool. Okay, well and I guess the only case where this could backfire is the wrong word, but where you could miss it was if all your tests was hitting the code that was not blocking, and then somehow you have an if statement that triggers a block that you didn't catch in your test. But that's,
that theoretically that could happen. Yeah,
it's much smaller in there.
But that's a problem of every test. Right? If you don't have good test coverage, it's not the fault of the framework.
Sure, but this is much. I like this approach because it lets. Because I was hesitant about this. Like, you probably should have async as non-async as the default, but just to avoid this. But I hadn't realized you could actually detect this. That's awesome. So we had a few more in here. There was Eve Chen. That says, can you still time a request with metrics?
Yes. We have implemented the integration with, let's see. You have integration with, there's JAXRS and JSON-B, there's security, there's metrics, there's tracing, there's Qt. I'm not sure if there's anything else, but all the important stuff that works with RESTEasy works with RESTEasy Reactive stuff. And if it doesn't, then try it out and let us know, and then we'll fix it.
It should work. And then I think we'll end on this note, which is the the big question. This was back against the program model. Like the big difference, Eve was asking, like, why were we not doing async all the time? And I think if we could, we would. But the program model just haven't followed. Like it's about the program model, not about what's performant. But then things have evolved. We've got more decent APIs, things like cut and coroutines. And then the product Loom that's being explored in the platform DDK is all things that should make this stuff, enable asyncs to be, available. Do you have any comments on the Loom thing? I've seen that comments come up elsewhere. Why would not just wait for Loom? Why don't we wait a few years before we do this?
Well, what are you supposed to do in the meantime, though?
Yeah.
Yeah, right. I mean, the problems we have with scaling are now. So, and the solutions we have are also available now. So in the meanwhile, we have all this technology that allows us to deal with scaling and getting better performance and handling requests. So this is what we have. And to be fair, the situation is definitely not as bleak as on JavaScript with callbacks, which they are not using anymore, by the way. They're using promises. So we have Mutiny, which is really great API, very user friendly, very innovative. Helps everyone learn about the API very easily and get productive fast. It's readable. It really makes it much easier to write async programming in Quarkus now. So that's a huge thing. And yeah, Loom is probably going to help several things and several types of workloads in the future. As to whether it will be as performant as what we have at the moment, it's not clear yet, because, well, there are various technical reasons as to why it could be as performant, it could be less, it could be more, but it's definitely not clear yet, and we also don't know when it will ship. There are various pre-releases that it's made, which mostly work but are not production ready, and so
plus that even when it does ship, most people are not going to jump on to JDK 18 or 19 or 20 or whatever it's going to be in their production setting, right? We still have people using Quarkus that use Java 8 and can't even move to Java 11, so.
Yeah.
They need solutions now, right?
Yeah. So one thing to mention too is just that. So where something like Loom is really good, or the whole coroutine notion is really good, is if you're taking a task that is actually written to be blocking and you want it to be processed in an asynchronous manner, right? So that's where it's good. That's not the best solution in all cases. So example, Mutiny is a streaming API at its core, right? So if you have a use case that is about streaming data from A to B, writing it as a blocking thing, which then gets mapped back to asynchronous, is actually more complicated and more work than just writing a very simple stream block of code, right? A few lambdas in there that just simply grabs data from A to B. So even if you had it available right now, you'd still want to use Mutiny and reg-to-style programming in a number of use cases. So there's not any big problem with switching to it today if you wanted to, because you probably will end up wanting to leave some of that code around. It'll just make the blocking cases that you have, maybe a few more of those could be remapped, where you didn't care as much and you don't have to spend time converting the code. So that's where I think Loom's really going to help.
Yeah.
And I just remembered something that I forgot. I forget it every time, but it's actually pretty important. If you use threads, even if they're Loom threads, they're cheap threads, whatever, they're not hardware threads, they're not OS threads. When you switch from one virtual thread to another, you still have to save the stack. So you have this piece of the stack that is your continuation from your coroutine. You still have to save it somewhere. And so in traditional Java EE frameworks, we have huge stacks. It's the same with Spring. They're like, whenever you see an exception, it's like 20, 30, 50, 100 lines long of the stack. Now, if you just switch and say, I'm going to use Loom or coroutines or whatever, and suddenly all your million coroutines have to save that stack anyway, the minute they need to cooperate with the others, you're still going to use a huge amount of memory. The fact that we implement everything in a reactive way asynchronous from the ground up, it means that the stacks that you use on Quarkus, on RESTEasy Reactive, on Vertex, on Quarkus normal, Hibernate Reactive, the stacks are going to be tiny. They're going to be super small, like 10, 12 entries max. And so with this model, with this implementation, if you switch to using coroutines at some point, you will save tiny stacks and your memory usage will be great. So even if, this work is definitely worth it, because the stack size is not going to be fixed by magic if you keep on using the blocking APIs that we have at the moment in traditional EE applications.
Awesome. Yeah, and I must say this every time I see it, like, it's funny, like 5-10 years ago when you talk Java, these things are just like we didn't even look at them, but now it's like what enables Java to actually be relevant again. So yeah, and Tokyo says, what is it? He says Loom is light on CPU but heavy on memory. I think that's his point. Similar sort of thing. So anyway, we are on the top of the hour and past it. Thank you, Steph and Georges, for talking about RESTEasy Reactive. And we got questions. And if I look at the live count, I think we got a record attendee for a Quarkus Insight episode. And this is also the last one of the year, so we actually gonna go on what's it called, hibernation?
Hiatus or something.
Hiatus for
on reactive hibernation.
Yeah, reactive hibernation. Yeah. And Jason has to jump. Yeah, we all have to drop. So yeah.
Awesome talk, guys. See ya.
Yeah.
Thanks.
So
See
we
you,
will be we won't be doing Quarkus Insights, at least for the next, I think, 3 weeks, because there's not enough people around to listen or people to host. But we will come back in January, and I am trying to get a Hibernate Reactive on in January. I don't know if it'll be the first one, but that's the goal. So anyway, thank you guys, and
thanks everyone for joining.
Thanks a lot, everybody.
Thank you. Bye-bye.
Bye.